Hello everyone. In this video, we're going to be solving a functional equation. So we're given a function f from positive real numbers to real numbers. Initially, I had written it as positives to positives, but we don't need to have positives. So we want to, have our range as the real numbers. And f is defined as, or given as, f of xy equals f of x minus f of 1 over y. Obviously, you do not want the y value to be 0 here, and that's why we want to go with the positive numbers, and also there's another reason. But don't get confused. Sometimes we write f of x as, and I think I've done this in one of the videos, that was a mistake, y equals f of x. When we write a function as y equals f of x, y just becomes the dependent variable. But in this case, we're kind of talking about x and y as the independent variables, and suppose it's kind of like, you can write it as t equals f of x, or maybe t equals f of y. So x and y are pretty much equivalent here in that sense. They are free variables. Anyway, so this is different. Y equals f of x is not what we're talking about here. So we have this function, and we're going to solve for f of x. Okay. Let's go ahead and replace, with functional equations, it makes sense to replace x and y with values, especially 0 is a good one, if possible. Of course, here you don't want to replace y with 0, you can't do it, but you could possibly replace x with 0, but again, you wouldn't do it because it's not in the domain, so don't worry about it. And we're not even going to worry about f of 0, but we can do something else. How about replacing x and y with 1. So let x equal 1 and y equal 1. Now this gives us f of 1 equals f of 1 minus f of 1. Something interesting, but f of 1 minus f of 1, regardless of the value of f of 1, is 0. So this implies that f of 1 is equal to 0. Nice. So we have a function whose value is 0 at x equals 1 or y equals 1 or whatever the value. Okay. Now, I want to replace x with 1 again, but this time I want to leave the y as 3. And that's a good thing. With functional equations, we replace x and y with values. Sometimes we replace, for example, y with f of x or negative f of x. Since x and y are free variables, we have a lot of freedom in that sense. We can replace them with different things. And keeping a variable free is a good thing sometimes. So let's go ahead and set x equal to 1 and let y be free. Okay? Which means y is going to be y. So f of y, because 1 times y, is going to be f of 1 minus f of 1 over y. This is really cool. First of all, the motivation behind this is we have a 1 over y, so that is going to give us an interesting relationship between f of y and f of 1 over y. Second reason is replacing x with 1 is a good thing because we already know the value of f of 1. So this gives us the following. Since f of 1 is equal to 0, from here we can write f of y is equal to negative f of 1 over y. So from here we can basically replace y with 2 and get a relationship between f of 2 and f of 1/2, so on and so forth. With 1, it's not going to help us because it's all going to give us f of 1 equals negative f of 1, which we already know because that's what we used. Anyways, I talked too much, so I should stop. So we're going to substitute something here, but notice that in our original problem we have f of 1 over y. So let's go ahead and isolate that. F of 1 over y can be written as negative f of y. So now let's go back to the original equation and substitute this. So we're going to sub. We have f of xy equals f of x minus f of 1 over y. And now we're going to replace f of 1 over y with this. And since it's a negative, it's going to be like a double negative. Since it's not English, it's just going to be a positive, right? So this gives us something very interesting. F of xy equals f of x plus f of y. Yay! We got Cauchy. Awesome. So Cauchy tells us that if this function is good, continuous, so on and so forth, it has some nice properties, then it has a good solution. And the solution is going to be f of x equals k times ln x. And remember, the x values are always positive because the domain is positive real numbers, and this is going to be well defined. Awesome. Now, are there any other solutions? K obviously is a free constant. What happens if k is equal to 0, right? Well, if k is equal to 0, then you're going to get f of x equals 0, and that's just going to be a constant function. Can f of x be a constant function? Yes. If you go back to the original problem, how can you verify that this could be a constant function? If f can be constant, then you can replace it with c, and you get the following. C equals c minus c, and that means c is equal to 0. So f of x equals 0 is also a solution to this functional equation. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.